Hey guys, it's Mrs. B again. I know it's been a couple weeks since we uploaded a video, but everybody's been going through things, trying to get everything set up for distance learning and just kind of figuring out what we're doing from now until school hopefully starts back again in August. Today for pre-algebra, we're going to look at reviewing how we classify numbers. We're looking at what typically in a teacher's lesson plan is called subsets of real numbers. So what we're going to look at, and we're going to deal with a lot of vocabulary today, and then some identifications and what things make things go places, okay? So what we're going to start with is we're going to talk about what do I mean by real numbers? What are the categories that real numbers go in, and how do I figure out once I have a number where I can put it, okay? So if we're looking at what we've got, any number we can think of, no matter how strange it seems, is considered a real number. So we got a big box for our real numbers. Then our real numbers can be divided into two categories. They can either be irrational or rational. Seems straight enough. Well, what does it mean if something is irrational? Well, we have the technical definition. It's a number who can be written, a rational number is a number that can be written as a decimal, a fraction that can be written as a decimal, with that is either either repeating or terminating. It's either a terminating or a repeating decimal. Can also be written in fraction form. What that means is something a little less complicated, and I'll explain in just a minute. An irrational number is a non-terminating, non-repeating decimal. What does that mean? Well, what does terminating mean? To terminate is to end. So if it's an irrational number, it has no end. Well, what do I mean by no end? If I put a number in the calculator, I'm going to, and say it's a strange fraction. Okay? So I've got my calculator, and I put 85 divided by 13. It's strange enough numbers. Okay, now what do I get? Well, let's look at that number. 6.538461585. Now, if I take, and the nice thing about my phone is I can turn it sideways. Well, I have more space, but am I guaranteed that that number ends, or did my calculator just kind of end it for me? With a number like this, my calculator ended it for me. There's no, okay? So let's just double check that. I'm going to do 1 divided by 9. Okay, now, you'll notice it only goes so far past the decimal. Now, have any of you ever tried to do 1 divided by 9 longhand? That 1 keeps on going. You never end up with, in long division, a number that doesn't have a remainder. You don't ever have something that'll let you completely get rid of the remainder. So if it has no end, it means that pattern, that number keeps going. It's like the number pi. Most of the time when we think of pi, we think of 3.14. But it's not, that doesn't stop, pi doesn't stop at 3.14. It's 3.1415297. I think I'd have to look it up. But, so it keeps on going. They have found pi to more than 1 million places past the decimal, and it's never going to stop. That's a non-terminating or non-ending number. So irrationals have no end. If I say that has no pattern, so that's non-terminating, non-repeating. If it has no pattern, we saw with, 9 divided by, or 1 divided by 9, it's 0.111111, which we would write on our paper as 0.1, and then we put the little hat over the top of it to let someone know that it's repeating. Okay, so, and we have numbers that happen like that. But if it says no pattern, That means I look at those numbers past the decimal and I can't find a spot where it starts to repeat. Numbers like pi. Well, let's see, what if I do the square root? Oops, wait a minute, let me go back here. My calculator to do things I want it to do. Let's see if we can find it. The square root of 2. Square root of 2. Is there a pattern in that? Almost, but not quite, because if you look down here at the end, there's not a pattern there. It's completely not a pattern. So square root of 2. What if I tried square root of 5? Oops, wait, no, that's not what I want to do. Square root of 5. Is there a pattern there? There's not. So that would be another one that would be considered an irrational number. Well, let's think about it. So if irrational numbers have no end and no pattern, rational numbers are going to do the exact opposite. They will either end or they will have a pattern. Okay, so when I did 1 over 9 and I got 0.1 and the 1 repeated, that's a rational number because it has a pattern and it repeats. Yeah, so, okay. What if I had negative 1/9? Is that still a rational number? It is, because it still has that. I didn't say anything about it having to be positive or negative. I just said that it had to either end or have a pattern. What about 0.75? Is that a rational number? Well, think about it. Does it continue on past that 5 after the decimal, or does it just stop? Does it end? It ends, so it has a termination. It has an end, so it can be a rational number. Now, I have a whole bunch of numbers I can classify as rational numbers. There's a huge collection of them. But then I get a little picky with rational numbers. I can then take those and I can scooch them into other sets. I can break down rational numbers, and there are some rational numbers that have their own space, have special characteristics. They're called integers. It would help if Miss Barbara could spell. But anyway, so integers, what makes an integer different from any old plain rational number? Well, integers are numbers that don't have decimals in them. They're like whole numbers, except it can include negative numbers and positive numbers. So the one thing that an integer doesn't have that a rational number does have is it doesn't have a 0. So it could be negative, like negative 532, negative 6, negative 8, whatever. It could be 0, it could be 352, it could be any number as long as it's a whole number, either positive or negative. Now, we talk about whole numbers when we talk about numbers without decimals. But there's a difference between an integer and actually what mathematically we call a whole number. An integer is any positive or negative. Well, it's the way most math teachers say it is all the whole numbers and their opposites, which means 0, and then 1, and all the way towards infinity in one direction, like you're going along the number line, the spots on the number line, and then you turn around and you go in the negative direction, the exact same thing, okay? But there isn't a difference between an integer and a whole number. A whole number is all those numbers we just talked about, except we don't include the negatives, okay? So if I'm talking about a whole number, I'm just talking about these guys. 0, 1, 2, 3, 4, 5, and on up. And so that, it's really important to know when I'm talking about a whole number, it has to be a positive number. And when I'm talking about an integer, it can be either positive or negative, but it can't have a decimal. And then the last piece of all of this, and the smallest category we have, is the natural numbers. Now, you're going, well, I thought whole numbers was as small as I could get. Well, the natural numbers takes one more step. In the set of natural numbers, we take out the number 0. So the whole numbers start at 0 and go up. The natural numbers start at 1 and go up. Think about it. When you first learned how to count, did you start with 0 or did you start with 1? It's kind of a natural inclination, kind of a natural idea that we start at 1 when we're counting stuff. So sometimes the natural numbers are called the counting numbers, but that just kind of that natural basic inclination is when we start with numbers, we start with 1. We don't start with 0. So when we're looking at this, we have clues. If it's any number we want is a real number. If it's irrational, when you put it in a calculator to check it, there's no end in sight and there's no pattern that you can find. But if you put it in the calculator and you end up with it ends or it has a pattern, then we've got to call it a rational number. And then we got to look at that rational number and go, are there any smaller boxes I can put it in? Well, if it doesn't have a 0, or if it doesn't have a decimal, sorry, doesn't have a decimal? I should say decimal, not 0. If it doesn't have a decimal, then it can be an integer. If it's a number like 86 or negative 35 or 1 or 0, that, or, negative 352, negative 5 million. Those are all integers because they're numbers that we write without a 0, right, without a decimal, okay? So now that we know that, we look at that and go, but sometimes I don't want the negative side, I only want the positive side. Well, that's when we call those numbers whole numbers, okay? And then sometimes we look at it and go, but I don't start counting at 0, I start counting at 1. And then those are the natural numbers, okay? So now, if most of the time when you see a problem like this, what they're going to do is they're going to go, okay, I'm going to give you a bunch of numbers and you tell me where they go. So if I give you the number 30, what categories can it go in? Well, we know always if it's a number at all, it's a real number. Okay. But is this a rational or an irrational number? Well, 30, it's just 30, it ends. So if it ends, it fits over in my rational side. Okay. Now let's look further down. Well, we know it's rational, but what else could it be? 30 doesn't have a decimal, so it's an integer. And it's positive, which means it's not a negative number, which means it can be a whole number. And it's not 0, so it can be a natural number. Now, the question can say which categories does it belong in, or it can say which is the smallest subset. Well, if it asks which categories can it belong to, you've got to give it the whole list. But if it wants the smallest subset, we're only going to that last one, which is natural. So let me take another number here. I'll pull out my handy dandy interactive notebook from this year. Okay. 5 4/7. 5 4/7. Well, let's see. What is 5 4/7 in my calculator? My calculator back up. Okay. So let's look. Clear that out. 5 and 4 divided by 7. Okay, so let's see what it says. Oh, wow. Do I have a pattern there? This is 5.5714285714. Now, do you see a pattern? If my calculator kept going, would I have a 28 here? If you get a calculator that will go more digits than mine will go, you'll find out that this right here, 571428, repeats itself every time as we go through this. So is this a terminating or a repeating decimal? It's a repeating decimal. It has a pattern. So not only is this real, it's rational. Okay, but is this an integer? It's a number with a decimal in it, so it can't be an integer. So I'm done. This is it. It's a rational number. That's it. It's finished. Okay. Well, what about, so everybody's seen so good so far. Now I have, the next number I'm going to do is the square root of 21. Turn my calculator the other way. So I have the square root, let's clear this out. The square root of 21. Oh my goodness, that I get 4.582575,695. Is there a pattern in that anywhere? Other than just a 5 coming up all the time. But is there a set of numbers that repeats itself in the same order? There's not, and this is not going to end just because my calculator ends the calculation right there. My calculator does what it calls truncation. It says I have a display space that will let me show so many numbers. So when I get to that last position, I'm going to round and just put up an estimate of what it should be. So this one is, again, it's a real number, but because it doesn't have a pattern and it doesn't have an end, it is irrational. Okay. Now here's a trick. Negative square root of 9. Now, when I put this in my calculator, am I going to hit the negative key? Or well, let me ask this way. Does the negative go inside the square root or outside the square root? Well, look at it. It's set on the outside. So I'm going to go ahead and put that in my answer. And then I'm going to do square root of 9. I'm not going to do 7 times the square root of 9. Let's try that again. So square root 9. And I get 3. Okay. Now, if I wasn't paying attention and I wasn't really thinking good and I did this and I wasn't thinking about it, and depending on how your calculator works, because in my classroom I have some calculators that you put the number and then you hit the square root symbol, and I have other calculators where you put the square root symbol first and then you put the number in. So you got to know your calculator. In my calculator here, I could do negative square root 9, and it keeps the square root outside of it and tells me my answer is negative 3. But what if I was feeling kind of froggy, and I wasn't paying attention and I did square root of negative 9? My calculator didn't give me an answer. There's nothing there, is there? My calculator doesn't like to do that because we learn square root is a number times itself, right? Or a perfect square is a number times itself. So to take the square root, you're going back to find that number. Well, can you take a negative times a negative and get a negative? Can I do negative 3 times negative 3 and get negative 9? You can't. A fact of multiplying integers is if you've got a negative times a negative, you're going to end up with a positive. So you got to have a negative times a positive to get a negative. But if I'm doing a square root, I want them both the same. So you've got to be careful how you put it in, or your calculator is going to frustrate you. Well, let's look at this. Assuming we did it right, the negative square root of 9 is negative 3. Well, we know it has to be real. Well, negative 3 just is. It's negative 3, end of it. So it has an end, which means it's real. It doesn't have a decimal. It's just negative 3. There's no negative 3 point something. So if it has no decimal, it's an integer. Now, it's negative 3. Can it be a whole number? Well, let's go check our chart. If it's a whole number, we have no negatives. So can -3 be a whole number? It can't. It's just, we're done at integers. Okay. Now, I'm going to put a couple down. They're a little bit of a challenge, but I want you to try them. I'm going to give you about 5 minutes to look at them and try them. Get your calculator out. If you need to, pause the video and see what you can come up with. So we're going to look at the square root of 144 divided by 3. We're going to look at -2.875. And we're going to look at the square root of 17 over the square root of 17. So those are the three. I want you to take the next 3 to 5 minutes and try on your own. Use your calculator if you need to. Okay, guys, we've had a little bit of time, and maybe not the full 5 minutes, but we've enough time's passed. So let's look at this. First thing I want to do is I want to get this in its simplest decimal form that I can, because that is going to kind of help us with deciding if it has an end, if it has a pattern, those kind of things. So let's look at this. I have the square root 144. Then I'm going to divide that by 3, and I get 4. So the square root of 140 was 12. Square root of 144 is 12, and 12 divided by 3 is 4. Well, let's look at this. We know this is a real number because every number is a real number. Well, it ended. So it has an end, which means it's rational. It's just the number 4. There's no decimal added onto it, so it's an integer. It's a positive number, so it's a whole number. And it's a number bigger than 0, so it's a natural number. So that fit in every single category. Now, if this was on a quiz or a test, we'd probably say something like, it could say either which subsets does this number belong to, or it could say what is the smallest subset that this belongs to. Well, our smallest subset is the natural numbers. But if I had to pick all the subsets, I would have to pick all of these to get it correct. Now the next one's a little bit easier, negative 2.875. Well, always we call them real numbers. It ends, it's 0.875. It ends, so it's rational. Okay. But it has a decimal. So can I call it an integer if it has a decimal? I can't. So this is it, it's done. Its smallest subset is the set of all rational numbers. The last one was a little bit trickier, but I want you to think about something. Any number divided by itself, standard math rule, any number divided by itself is always 1. If the top and the bottom of the fraction match, those pieces are going to cancel each other out and leave 1 behind. Well, 1 is a real number. It's rational because it ends. It's an integer because it doesn't have a decimal. It's a whole number because it's positive, and it's a natural number because it's bigger than 0. So this is another one that would fit in all your categories. The best way to get good at doing subsets of real numbers is to go in and to practice. Recite those rules to yourself. Recite those meanings to yourself. Go make a copy of this little chart. Make yourself a real numbers chart over and over again that says, if it's an irrational number, it has no end, it doesn't have a pattern. If it's a rational number, it ends or it has a pattern. If it's an integer, it doesn't have a decimal. If it's a whole number, it doesn't include negatives. If it's a natural number, it doesn't include 0. And just do that till it kind of becomes a part of your memory and what you think of and what you do. All right, go practice, go online, look up practice worksheets. They're there. All you gotta do, if you type in subsets of real numbers worksheet, a bunch of things will come up. Print one off, try it. Use your notes that you've taken from this video. Use your notes that you've taken in class. Practice it till you are so good that if somebody says, what makes a rational number? You can say, it's a real number that has no end or has no pattern. Just get those till you internalize them. All right, guys, have a good evening or afternoon and keep practicing.